Welcome to Easy Maths. In this lesson, we're going to be focusing on the second half of the series of lessons on the topic of sequences and series. Particularly, in this lesson, we're going to look at the nth term, or a formula for getting the nth term for a geometric sequence. And so as we begin, let's consider the sequence below. We have 1, 5, 25, 125, and 625. Clearly, the common ratio in this case is 5. And the first term is 1. Now, as for our analysis, let's list these numbers as shown here below, where we have 1, 5, 25, 125, 625, and we could have others up to the nth term, which we are going to try and have an analysis about. Now, obviously, this one can be written simply as 1, and it's also a, the first term. Now, the 5 can be written as 1 times 5, which is the same as a times r, where a is the first term and r is the common ratio, as we had earlier here. That is the second term, and that term can be written as 1 times 5 squared, which is a times r squared. The fourth term can be written as 1 times 5 cubed, which is a times r cubed, and the fifth term is 1 times 5 raised to the power 4, which is a times r raised to the power 4. And of course, now the students can see a pattern that is already observable here. Now, this pattern will guide us in getting a formula for for the nth term. Now, please notice that for any term, we have a times r, or a times something. In the first term, we have a only, although this is simply as a times r raised to the power 0. R raised to the power 0 meaning equaling to 1, therefore it's just the same as a times 1, which is a. When we are at the second term, we have a times r. At that time, we have a times r squared, the fourth a times r cubed, and the fifth a times r raised to the power 4. Kindly notice that we have a times, and then the r, which is raised to the power that I want us to consider. When we are at the fifth term, we have fifth term r is raised to the power 4. Fourth term, it's power 3. Third term, it's power 2. Second term is power 1. And the first term is power 0, where we were saying r raised to the power 0, which is 1. Now that tells you something. We can always know how to obtain the nth term for any geometric sequence. And how will that be? It must be a times r raised to power n minus 1. The same way we have 4, which is equal to 5 minus 1, or 3 here, which is equal to 4 minus 1, or 2 here, which is 3 minus 1, and that pattern should be the case there. And so the nth term for a geometric sequence is a r raised to power n minus 1. Also, please take note of that the nth term for a geometric sequence should always be given by a times r raised to power n minus 1. Now, for our practice, we have a question here where we're told write down the common ratio in each of the following sequences. We have a, 4, 20, and 100. With that, we should know that the common ratio obviously will be the ratio of consecutive terms. In the list that we're having here, 5 is the same as 5 divided by 1, same as 25 divided by 5, same as 125 divided by 25, and that should be constant, and all time should be equal to 5. And therefore, for part A, the common ratio will simply be 20 divided by 4, which is the same as 100 divided by 20, which is 5. For the second part, which is CA squared, the common ratio must be CA divided by C, which is the same as CA squared divided by CA, and obviously the answer is simply A. For the part C, the common ratio should be minus B divided by B, or B divided by minus B, or minus B divided by B, and the answer will simply be -1 in all of those cases. That brings me to the end of that lesson on the introduction to concepts that have to do with geometric sequence. Please check out for the next video. We're going to be looking at other examples that will try to show us how we can use this knowledge of the nth term to tackle exam standard questions. As always, please like, share, and subscribe. I'd appreciate it. Thank you.